Okay, so this course is titled Neuroethics in HPP and EBRAINS, and is taken by Kathinka, me, and Manuel. In this very brief outline, the idea was to present what we should have analyzed in the course. So what, why, and who. Specifically, Kathinka will present how neuroethics has been generally conceived as a discipline, and also how it has been practiced and conceived within the HPP. Then the idea for the breakout rooms was to present a couple of case studies, but this will be postponed. Maybe we can just mention what are the topics of these case studies. And then a final reflection about the connection between neuroethics and EBRAINS as the legacy research infrastructure of the HPP. And this was supposed to be a kind of brainstorming part of the course, because the specific role of neuroethics in connection to EBRAINS is something still open to debate. And so it is something still under reflection and under analysis. So very briefly, well, this is maybe not necessary because all the participants, I think, have familiarity with the HPP, so let's skip this slide. What is the rationale of this course? Basically, we would like to discuss the neuroethical relevance of both HPP and EBRAINS. With this, we mean the fact that both HPP and EBRAINS raise ethically relevant issues, and so they both deserve an ethical analysis, a specific ethical analysis. But we wanted also to discuss the relevance of neuroethics to HPP and EBRAINS, the fact that neuroethics as a discipline is something that can offer kind of added value to both HPP and EBRAINS, especially in order to connect more HPP and EBRAINS to civil society, to the public. Then we also wanted to discuss how to operationalize neuroethics analysis and recommendation, how to bridge the theoretical reflection and the practice, the scientific practice and the technological endeavor. And also we wanted to discuss the key capacities that should be enhanced in researchers in order to create this link between science, technology, ethics, and society. So this is, very briefly, the what is about this course. Then why? Well, the idea behind the course is that neuroethics should be taught and reflected upon globally and interdisciplinary, because we should all learn from each other, because everyone brings his own background in terms of discipline, but also in terms of culture. And this is very important when you reflect about the ethical implication of neuroscience in general and HPP specifically. And also, the mutual relevance of neuroethics and neuroscience is something not naive, not trivial, not self-evident. So this mutual relevance needs to be justified. And for this justification, it is crucial to identify key capacities to enhance in researchers and all the stakeholders involved, actually. So this, in a nutshell, is the rationale, we might say, of this course. And now I can leave the floor to Kathinka for an introduction to neuroethics in general, and neuroethics in the HPP specifically. Kathinka, do you want to share your presentation? Should I stop sharing my screen?
Yes, why not? Excellent. Well, I have led the research on neuroethics and philosophy in the HPP since the very earliest planning stages of the project, actually. And it's been a very, very interesting journey. As it started, the research in the HPP on these matters, it has 4 cornerstones. Anticipation, which is foresight analysis of social and ethical concerns. Reflection, which is conceptual analysis, also including researcher awareness. Engagement, where we have public and stakeholder dialogue and feedback. And action, where we identify strategic pathways to social benefits. So there have been research theoretically in different domains, philosophy, ethics, social science, and engagement, but always also with a view to practical applications and actions. The first 7 years, we had a specific sub-project, 12, that was dedicated to ethics and society activities, comprising the Foresight Lab, Neuroethics and Philosophy, public dialogue and engagement, and ethics monitoring. This was always in close collaboration with other sub-projects, but for the last 3 years of the HPP, we have changed the structure. Now we have a specific work package dedicated to what is called the RRI activities, responsible research and innovation, whereas most of the neuroethics and philosophy tasks have become embedded within the science work packages. So it's a different structure. We now work within, most of the time, within the scientific work packages in close collaboration with them directly. Now, we may ask, first of all, what is neuroethics? It's a rather new discipline, so it's reasonable to wonder what it is and what we do. Now, an old distinction separates the ethics of neuroscience from the neuroscience of ethics. The ethics of neuroscience discusses ethical issues that arise in neuroscientific research and evaluates the ethical and social impacts that those results of neuroscience have or should have on social and legal structures. The neuroscience of ethics rather looks at how understanding the brain might inform us about our normative thinking, our normative evaluations, for example, moral thought and decision making. This is a useful and interesting distinction, but of course it is not all-encompassing. A different approach separates fundamental neuroethics from applied neuroethics. Fundamental neuroethics pursues basic research and analyzes foundational concepts and methods used in the neuroscientific investigations of notions, for example, like simulation, identity, consciousness. And these analyses necessarily involve both the empirical scrutiny of the science in question and philosophical analysis of the concepts involved. It aims to provide the adequate theoretical frameworks, but in addition to the theoretical interest of these frameworks, we always point out that they are necessary in order to properly address the practical issues of applications. And this is where applied neuroethics come in. So it's a bit, to paraphrase Kant, that theory without practice is empty, whereas practice without theory is blind. These two are mutually supportive. In the HPP, fundamental neuroethics has prevailed. So we have done very much basic research within a multidisciplinary domain using an interdisciplinary methodology. We have, many of us are philosophers, so we have done conceptual analysis of key scientific and philosophical notions, but we also, and importantly, involve sociologists. And sociological analysis of scientific and philosophical interpretations are also primordial in this context. So we do both conceptual and social analysis based on empirical data and reflect on key terms today, such as digital twin, virtual brain, consciousness, artificial intelligence, interpretations, and other concepts of relevance to the HPP scientific work. We have right now 4 neuroethics and philosophy tasks. 3 of them are embedded in the science work packages, and 1 is a task in the RRI work package. And these are the tasks. The impact and implications of personalized brain modeling, philosophy of cognition and consciousness, and ethics and philosophy of AI and bio-inspired modeling. And the task in the RRI context is neuroethics and engagement. All of them have a close collaboration with the dual use working group and the ethics rapporteur program. Now, when the goal is to enhance or build capacities, as this course and later other activities and services in EBRAINS, we hope, different types of neuroethical inquiry are pursued in distinct scientific domains and therefore require diverse capacities and strategies developed for specific aims. And in this course, we have planned to develop that with two scientific cases where neuroethics have tasks to collaborate: research on consciousness and research on the virtual brain.
Okay, here we are. So as Kathinka mentioned, we are now, as a neuroethicist, we are now embedded in some task within the HPP, and one of the tasks where we are, one of the work package where we are embedded is work package number 2, which is about cognition and consciousness. And our task is 2.7, which is about neuroethics and philosophy of cognitions and consciousness. And within this task, we have been reflecting upon one of the main open issues of contemporary clinical as well as scientific study of consciousness, which is how to attribute consciousness to patients in disorders of consciousness. A couple of years ago, more or less a couple of years ago, we published a paper together with Cyril Pernars, who is a cognitive neuroscientist, a paper about indicators of consciousness in animals and intelligent machines. Indicators are conceived as features, observable features that can reasonably suggest that the subject in front of us is conscious. This in a nutshell, of course. And we identify some key features that reasonably suggest that animals and AI system in that case are conscious. And in a follow-up study, we applied this framework to patients in disorders of consciousness. Disorders of consciousness mean a very impaired condition of consciousness, like a vegetative state or minimally conscious state, which are impairments following trauma, for instance, had trauma or whatever, and can lead to to the brain death in the end, or the patients can be in these conditions for more or less time. So we have a big problem here in terms of clinical management, but also of ethical decisions. So the point is of this specific effort was to explore whether these introduced indicators of consciousness can be applied to these clinical populations, to these patients. And we work together with, with also clinicians and scientists. We work and we submitted a paper about the ethical relevance of these indicators with this specific case in mind. And I'll skip some slides that are not really relevant to this briefer discussion. So we identify some characteristics of consciousness. And one of the main points that we highlighted is that in these patients, it is possible, it is reasonably possible that the residual consciousness is very different than the consciousness of healthy people. So we have another problem here, which is to avoid any kind of bias, we might say, in order to identify residual consciousness in these patients. So the situation is even more challenging and tricky. And I mean, the identification of these features and the reflection about how these features are possibly present in patients with dogs is an example of the multidisciplinary collaboration within the HPP, because we are together with clinicians and neuroscientists, philosophers, ethicists, we are reflecting upon how to to eventually look for these characteristics in subjects that are very seriously brain damaged, and then can show a different kind of experience than healthy people. So these are the features that we identify that can be attributed to consciousness. I now don't have time to go into the details. If you are interested, of course, we can discuss later. So we identify intentionality, integration, situatedness, qualitative richness, dynamics, and stability. And we, of course, reflected upon how these characteristics can be differently shown in patients with disorders of consciousness. And the indicators that we identified are goal-directed behavior, illusion and multi-stable perception, visuospatial behavior, episodic memory, some brain anatomy and physiology signatures, and psychometrics and metacognitive judgment. And we speculated about how these different characteristics and indicators can be detected in patients with disorders of consciousness. And our conclusion was that applying these indicators of consciousness to patients with disorders of consciousness can be a big help in order to identify and assess important ethical issues, like, for instance, the misdiagnosis of these patients, because more or less 40% of patients with disorders of consciousness are wrongly classified as vegetative state rather than minimally conscious state. These two different diagnostic labels have huge implications in terms of treatment, because for vegetative state, the prognosis is pretty bad, while for minimally conscious state, the prognosis is much better. And so the therapeutic protocols are completely different. So it's crucial, of course, to rightly diagnose these patients. And so this is just an example of how research from the HPP can play a role in improving the diagnosis and then the treatment of these patients. And just to finish, we are now working together with 18 researchers from WP2, but also from WP3, to a live paper, which is a paper that will be linked to live material, live data on eBrain. And in this paper, we start from an ethical analysis of these topics, and then we review relevant scientific research resulting from the HPP. We will have a meeting actually tomorrow, and we are pretty advanced in this paper. And this is another example of how neuroethics embedded within the scientific work can result in very interesting, at least I hope, very interesting inter and multidisciplinary research. Okay, I think I can stop here and leave the floor to Manuel and Kathinka for the other case.
Okay, thank you, Michele. I will also try to be brief. I'm going to present then the research on the virtual brain in the HPP, and what the neuroethics and philosophy researchers do in that area, how we collaborate. So computational brain models are developed both in the HPP and in other projects. For example, the European project NeuroTwin, for applications in the clinic to personalize interventions and treatments for brain disorders. And both of these two projects include research in neuroethics on social and ethical implications of personalized brain modeling. I lead that research together with my deputies in the HPP, Maxime Guy, and in Neurotwin, Manuel. So the virtual brain is the result of 20 years of research. It relies on artificial intelligence and machine learning and aims to radically change the management and treatment of brain disorders and pathologies. The brain imaging technology has led to the development of data-driven brain models. Now, I will go through these technical slides rather rapidly, but I do want to point out that for those of you who are interested, they will be accessible on the internet, so you will be able to go back and look at them and scrutinize the details after this discussion. Now, the vision of the virtual brain technology is to have these virtual brains as personalized brain network models informed by individual structural brain imaging data. And they are sometimes called digital twins, models that act as in silico simulation platforms capable of generating patient-specific brain signals. And in a clinical translation, the diagnostic and therapeutic interventions are optimized in virtual brain simulations adapted to each patient. So, well, maybe I will not go through these technical details. The idea is to create, or the vision is to create a comprehensive clinical platform that will improve the management and treatment of patients' brain disorders and pathologies. In the first clinical application of the virtual brain, one has focused on the virtual epileptic patient to support the very complex and often not very successful epilepsy surgery. There is a crucial need to reduce the risk in this type of surgery of focal drug-resistant epilepsy of epileptic patients. Drug-resistant focal epilepsies are severe diseases affecting people across all ages. It's about 1% of the world population that suffers from this, with a very high morbidity and mortality. And in a first clinical applications, the idea is to assist the surgery to reduce the risk of surgery failures. And in the virtual epileptic patient clinical trial EPINOV that was carried out in France in 13 clinical centers using 400 prospective patients during the years 2019 to 23, the results were very, very promising so far. There is an excellent performance, and the VEP, as they call it, performance is comparable to expert performance with positive surgery outcome. So I'm not going into the technical details here, but simply phrased, there is a very, very cutting edge, how should I say, simulation technology that goes beyond simulation, because there is a feedback loop between the model and the physical object that the model is about, which is why it is also called a digital twin, that promises to greatly help the personalized medicine and treatment for patients in particular with drug-resistant illnesses. Now, one of the first things that philosophers and neuroethicists do is to highlight the concept of digital twin. Traditionally, this has been used in industry and production, notably aviation. And here, the virtual physical integration that is enabled by the digital twin has played a very important role. But an important feature of the DTs in that area is that the objects that they replicate are manufactured. They are designed and built by humans, and as such, they have a high degree of transparency. We know them in great detail. In contrast, the application of the DT paradigm to living objects represents, albeit a promising development in medicine, but it also stands confronted with important challenges over and above those that the DTs of manufactured objects encounter. We are still in the process of discovering the live organs such as the heart or the brain, of which digital twins in medicine are now developed. So we stand confronted with a different type of challenge. And so, as a discussion here, generally phrased, in view of the outstanding structural and functional complexity of the brain and our rather limited knowledge of its functional architecture, is it even rational to attempt to build a virtual twin of that object? Does it even, or is it simply a pharaonic idea? Now, the objectives of the neuroethics research on the virtual brain is to provide the conceptual clarity necessary to adequately construct and discuss research on personalized brain models or digital twins of individual brains, and to suggest how to address and communicate the main ethical and social implications. Our method uses largely a philosophy of science framework to examine the validity of these virtual models beyond statistical and mathematical terms, notably to assess their biological realism. And here we address two core features of the brain that pose particular challenges to the construction of virtual brains: the phenotypic variability and neuronal epigenesis. And then, of course, we also focus on how virtual brain models of, in this case, epileptic patients may meet those challenges and show their usefulness in the clinic. So I will just skip this. How difficult it is to achieve a digital replica depends both on the ontological complexity of the physical object, how complex it is, and on the epistemic transparency, how well we know it or not. Generally speaking, a simple object is easier to know, but that is not always the case. It's not necessarily the case, but as a thumb rule, one can say that. In the case of the brain, we know that it is subject to important contextual and cultural epigenetic influences. So, in trying to model the brain, you have to consider the experienced brain in a body. Brains don't exist in a vat. Neglecting experience sets a severe limit on the construction of a virtual brain. On the other hand, taking it into account is a daunting task per se. So how does this feature affect brain modeling, in particular the digital twin? Then the individual variability. Each brain is unique, and this is a challenge for modeling that strongly impacts the outcome of treatments for a number of conditions, since distinct individuals may react quite differently to the same kind of intervention. So the question arises, how well is the individuality of the patient reflected in the personalized models? So looking also at the concept twin, reference to the model's twinness is problematic because the virtual brain is not a virtual copy. And the scientists are not saying that it is a virtual copy. Nevertheless, they use the term digital twin. This is not a minor point because the virtual brain's conceptualization might force us to re-articulate goals that has the potential for shaping societal expectations and informing policy considerations and regulation. So different types of issues arise here that one might address from different angles. We have epistemic questions concerning knowledge, ontological questions concerning the nature of reality, ethical questions, social questions, and regulatory questions, for example. And the key questions that I was going to suggest for discussions are, is the endeavor to build virtual brains realistic, useful? Is it risky? How well is the individuality of the patient reflected in the personalized models? And is digital twin really an adequate label for virtual brains? Do issues of patient integrity and/or privacy arise in this context? And how can neuroethics contribute to addressing these issues? And finally, are there any specific recommendations for building or enhancing capacities relevant for identifying and addressing these issues?